Okay, good morning. Welcome to
FamilyMath number 723.
FamilyMath723. So today we're going to revisit a famous unsolved problem in math, where I start with a number, and then if the number is even, I divide it by 2, and if it's odd, I multiply by 3x plus 1. Do you remember what this idea is called?
It's Collett's conjecture.
And what is the Collett's conjecture?
So it says any any integer x value you use will always go back to 1.
Okay.
So,
Why don't you show me?
So if you pick like an x value, maybe say like 7, then you can just, it'll say that this will eventually get to the point where it'll get to 1
Okay.
by doing this repeatedly.
Alright. By the way, what happens when you get to 1?
So 1, and then it goes to this 4, back to 2, to 1, so it just repeats itself.
Alright, it becomes a loop once it gets to 1.
So should I just do this?
Yeah, definitely.
So, let's see, this goes to 22.
Okay.
Divided by 2 is 11. Then 34. 17. And 2. 26. 13. 40. 20. 5. 16. 8. 4. 2. 1. And then it'll repeat.
Okay.
So this does eventually get down to 1 and then repeat.
It's an unsolved problem that if it works for every integer.
No one's ever found an integer where it doesn't repeat, doesn't go to 1.
It either just keeps bouncing around, or it's a different loop other than
It's
this.
different.
Right.
Yeah, no one's ever found it.
Right, that's a good point. It could start looping somewhere else, or it could just never loop. So what are some things you notice about this particular sequence?
Well, as soon as you get to a power of 2, you're finished.
Ah, interesting. Okay. So along the integers there are sort of almost like markers.
Yeah.
And if you ever land on one of those.
Then it goes to 1 and you're done.
Okay.
I guess if you see here, if you land on any of these numbers across here, then we know from this we know that all of these numbers in this list don't work.
Oh, that's another good point. That once we have tested a number, and this is 20 steps maybe,
Something like that.
then we can cross out all of those other numbers, and we know those numbers also go to 1.
You can just start anywhere. You could start at 17, or you could start at 40 if you wanted to.
Yeah, that's actually really interesting. And then there's one other interesting thing. It's not super obvious right from the start, but like notice 16 here. Where did we arrive? How did we get to 16 in our sequence here?
From 5.
Okay.
But you can also get to it from 32.
You can also get to it from 32.
So you can get to. I don't think all of the numbers, but you can get to some of the numbers 2 different ways.
Okay. Yeah. Well, which numbers do you think you could get to 2 different ways?
Like, for example, you can get to 7. You could get to this. You get to it from 14, or you could get to it from Well, no, because you can't get to it from 2 because that's even.
Ah. Okay. So you might think that 3x plus 1 could get you to 7.
But only if that 3x is odd.
Yeah.
So it's 1 mod 3, but that has to be odd. x, this number has to be odd.
Okay.
It has to be one more than an odd multiple of 3.
More than an odd multiple of 3. Okay. Cool. So now we're going to look at a different version of the Collatz conjecture that I learned from reading a paper by John Conway.
Okay.